Good day. We continue chapter 1 and 2 with section 2.5 variables and arrays. A variable is an identifier used to represent a single data item. Data assigned to the variable can be accessed by referring to the variable name. Here we have two C statements where X, A, Y, and Z they are all variables. An array is an identifier referring to a collection of data items all having the same name. In this example, we have char letter. So letter is a character array, size 40, and it stores string constant skudai. It's a one-dimensional array, size 40. You can store a maximum of 40 characters. To access the elements of the string constant, we use the subscript or index, array index. For example, S is stored in letter 0, K is in letter 1, so these numbers, they are all index or subscript of the array. Next we have X is integer array. It has three one-dimensional integer array. Size 3, it has 3 elements. So this is going to be x0, x1, x2. Here we have floating point variable, floating point array variable, k with 4 elements. It's going to be k0, k1, and so on. Remember, in C, array index or subscript starts from 0. Declarations. A declaration will associate a group of variables with a specific data type. In C, all variables must be declared. Here we have A, B, C declared as integer variables. Next, S1, S2 declared as floating point variables. Flag is declared as a character variable, whereas text is a character array variable. Normally we just drop the variable, we just say character array, size 80. Here, A is a floating point single position variable, B is a floating point double position variable, C is a long float. Long float is also equal to double. It's also a floating point double position variable. The difference between single position and double position is, for single position values, the magnitudes vary from 10 power minus 38 to 10 power 38 with 6 significant figures, whereas double position values, the magnitudes vary from 10 power minus 308 to 10 to the power 308 with 18 significant figures. In normal cases, we just use single position because double position will use a lot of memory. When we declare variables, we can assign initial values to the variables. Here, we don't assign values to the variable. So C is integer variable. It has an initial value which is integer constant 12. Star is a character variable with an initial value which is asterisk is the character constant stored in star. Y is a double position variable with an initial value 0.02 times 10 to the power minus 6. Here we have text is a character array without a size, but it has a string constant UTM, so the compiler knows that there will be 3 plus 1, so there's going to be 4 elements of text. Size of text is going to be 4. Why 4? Because at the end of string constants we must have the /0 end of string marker. We could have also written explicitly char text has 4 elements, UTM, and an extra /0. Expressions. An expression represents a single data item or combination of data items interconnected by one or more operators. So plus, equal, these are all operators, less than, your operators. These are expression. To compact expression, plus plus I or I plus plus is basically expanded form is going to be I equal to I plus 1. A statement, only statement. A statement will cause the computer to take action. You cannot type this in a C program. To convert this to C statement, you have to put at the end there semicolons. There are three classes of statements: expression, compound, and control statement. An expression statement consists of an expression followed by semicolon. So these are all C expression statements, including the now statement where nothing is done. A compound statement is made up of several statements enclosed within these two brackets. So here we have a compound statement made up of three expression statements. And here we have control statement where we have a looping operation. While this is true, perform all this. We'll come to this in detail, come back to this in detail later on, later chapters. Symbolic constants. Symbolic constant is a name typed in capital letter, and the symbolic constant represents either numeric constant, it can be a character constant or string constant. So here the keyword is pound sign defined, the symbolic constant self, and the value stored in that symbolic constant. The first one we have defined pi 3.142. This is effectively pi is equal to 3.142. It keeps a floating point constant 3.142. True in this case has a value integer 1. Friend in this case is going to keep this string constant. They are usually defined at the beginning of program. The data stored in symbolic constant cannot be changed once defined. In this example, you want to calculate area of circle. There are two variables. Those are floating point variables, radius and area. Here we define our symbolic constant pi, printf radius. So this printf enter radius. This statement will, this string will appear on the screen. We enter the data, hit the enter key, and then area is calculated here. Printf the content of area. Area is floating point, so the format is going to be %f. All this formatting, floating point, integer, and so on will be in the next chapter. When I execute this program, I enter the radius for print on the screen, area of circle equal to whatever value calculated here. Thank you.